going to have 40 kids down in Houston. Well, 30 kids and about 10 teachers. And that's going to be fun. I mean, it's going to be a life-changing event.
The hydrofuge is it's a small module that'll hopefully go up to the ISS and be able to grow small plants in space.
The idea is that an astronaut can take one of these and plant something in it, grow it, take care of it, have some fruit, have some vegetables, have whatever they want to have grow in this thing.
It's a 10 by 10 by 15 centimeter cube that's designed to grow plants in space.
And eventually the idea is that it could be modular and you could attach a whole bunch of them together and essentially create a garden of these things to grow enough food for deep space travel.
This is what we call our teardrop shape, and the point of this shape is this angle at the bottom here is approximately 80 degrees, and that attracts water in zero gravity because, with no gravity, the water cannot automatically be sucked down to the bottom of here.
If you were to be an engineer out at an aerospace company, you might be put on a project just like this.
It's just pretty impressive to have an environment like Lakewood High School or Warren Tech where students get to do real hands-on opportunities to prove what they've learned and take it to the next step.
You're learning project management skills, you're learning time management, you're learning collaboration, you're learning research, manufacturing, all these things that really aren't in a standard textbook.
It's something that we've been working towards. I've been working towards personally for a year, and they've been working towards for 5 years, and we've put a lot of effort into this, and putting it on the ISS is our dream.
Yeah, it'd definitely be a great accomplishment because this module hasn't been to the ISS before. It's really like the top milestone. It's really the big goal that we're shooting for.
Well, originally, I knew other programs that were involved with some HUNCH projects, and I wanted to look for something that would be in the human physiology area that would relate to exercise to go along with my sports medicine program for some of my second-year students.
So right now we're having our exercise to see what her heart rate, her blood pressure, and her calorie burned is without the suit. And then tomorrow we'll come back with the suit on and we'll test her doing the exact same exercise to see if there's a difference between her heart rate, her blood pressure, and her calories with and without the suit.
The idea was to help develop a suit that would augment what the astronauts are doing already in space. It would add additional resistance for everyday activities and or when they're doing their workout activities that they already do.
The t-shirt washer is an interesting design to solve a common problem in space with the International Space Station, and that's not being able to wash your clothes. So up on the ISS, it smells really bad, a lot like a stale locker room. And so what the t-shirt washer is trying to help with is just the bad smell.
NASA wants us to invent a zero-gravity t-shirt washer for them so the astronauts can feel at home, they can wear clean clothes.
Imagine living in a tin can for a year without being able to wash your clothes. Right now basically what they do is send them out. They wear them and then they're gone. They throw them out.
I am the leader of the team, but leader's just a title. I'm just the one who kind of guides people, tells them what to do. They come to me if they need something. But other than that, I don't micromanage too much.
My specific role is machinist expert, so I do all the kind of the building and the manufacturing of the prototype itself.
With engineering, I think I learned a lot about critical thinking. Stuff, you have a couple parts you want to choose and you really go through, make sure that's the part you want. That's the one that's going to work the best. Working with teams, it's not that big of a deal because the team I'm working with is great. They always communicate, they're funny, they do what they're supposed to do and they do it well. Through
this experience, I've learned that engineering, you have to be really specific, take everything down. You get to work with friends, you don't have to just be sitting behind a desk the entire time. Like I said, it's a lot different than I thought it was going to be, but I love it. It's a lot of fun.
I am the HUNCH advisor for our Warren Tech Central crew.
I have been the computer expert and the electronics expert on this project. This egg cooker is a project for HUNCH that will allow astronauts to cook and eat fresh eggs on the ISS.
The egg cooker started about 3 years ago with the Armadillo. The Armadillo is this George Foreman cooker that we turned into cooking just eggs.
And it's been a goal for NASA to have a way to have fresh food on the ISS rather than having just paste.
Reason for eggs was because we were looking for protein for the astronauts to have something really good to eat, and who doesn't like a fresh cooked egg in the morning?
We've simplified it to be a single button interface. So a button press to start preheating the cooker and a button to run the actual cooking process.
Then it warms up these Peltier plates. Peltier plates are thermoelectric plates that heat on one side, cool on the other. So we're using the 2 Peltier plates to heat an egg dish that has the egg inside of it, made out of aluminum, and it's acting as a heat sink. When those plates heat up, they heat up the inside, and it's drawing that. So it's cooking that egg, whatever is inside, or whatever food we have inside that plate.
What's really cool to me is that I'm doing and applying my knowledge and learning, not just to regurgitate that information back to somebody, but to apply it to a real, tangible product.
The robotics competition is something new that we're trying out this year. And so what we're doing is we have VEX robotic kits. We have 16 of them. And so we had the ground crew and the flight crew build robots, and they're all dispersed onto different teams. Now they are competing over different obstacle courses like craters and caves to get points and find valuable resources on this new planet that we're kind of looking out for, kind of like the Mars rover does.
Y'all are working on a European physiological module.
European physiology module.
European physiology module.
EPM stands for European Physiology Module.
We currently are working on the European Physiology Module, which is a prototype to build project. We get an idea, and then we're supposed to design it and then build it.
And y'all are building the front of it and 5 different enclosures or storage areas that are inside the rack.
It tests the effects of space travel on the human body. So it's got a cardio lab, it's got a hard drives areas for that to be stored and collected so that Johnson Space Center can see the effects of what's happening up in the ISS during space travel.
So we're participating to help them use a new training module for the ISS. And what the cardio lab is to help watch, like your life support and the pacemaking and everything.
Some astronaut up on the space station took a picture of the European Physiology Module. They brought that picture down here, blew it up to a poster size, and our students took measurements off of that poster and put it into a computer-aided drafting design program, drew blueprints for these plates, the front plates, and then those blueprints were given to our welding students and welding instructor, and they cut out these pieces of metal. Our graphic design program designed the templates or the coverings that have the written information on it, and then our STEM students will put it all together.
And actually build and bring this in April to the training facility that they have a mock-up of the ISS in, and they're actually going to install this in the Columbus module.
It's a once-in-a-lifetime kind of thing, to be able to work with NASA, and also, as a high school student, it's really, really astounding.